In this video, we'll be learning about 19 AWS Lambda strategies. I'm Chris, Cloud Architect, founder of SystemsArchitect.io and CodeGuides.io. Serverless promises you never have to think about servers, yet the gap between a Lambda function that scales effortlessly and one that burns money on cold starts and timeouts comes down to a handful of design decisions. This covers 19 practical strategies for fast, resilient, and affordable AWS Lambda functions, spanning performance, error handling, security, networking, and deployment. 19 AWS Lambda strategies. 1. Optimize cold start times. 2. Lambda layers. 3. Efficient error handling. 4. Monitor and analyze performance. 5. Optimize memory and timeout settings. 6. Environment variables. 7. Design for statelessness. 8. API gateway integration. 9. Utilize event sources. 10. Adopt function versioning. 11. Optimize code size. 12. VPC integration. 13. Asynchronous invocations. 14. Employ provisioned concurrency. 15. Enable X-ray tracing. 16. Built-in security features. 17. Manage dependencies efficiently. 18. Utilize resource-based policies. 19. Optimize deployment pipeline. 1. Optimize cold start times. What exactly is a cold start? A cold start happens when Lambda spins up a fresh execution environment, adding latency before your code runs. Keep critical functions warm with scheduled invocations, or use provisioned concurrency to pre-initialize instances that respond instantly. Provisioned concurrency adds cost, so reserve it for the latency-sensitive paths that genuinely need it. In 2025, Graviton-based runtimes cut initialization time by up to 40%. 2. Lambda layers. Lambda layers let you package common libraries once and share them across many functions. This shrinks each function's package size, speeds up deployments, and centralizes version management. When you patch a shared dependency, you update the layer instead of redeploying every function by hand. Keep in mind, a single function can use at most 5 layers. 3. Efficient error handling. Serverless functions fail in ways you do not always control, so design for failure up front. Build explicit retry logic and route failed events to a dead letter queue or DLQ so you can inspect and replay them later. Make your handlers idempotent so a retried event does not double charge a customer or duplicate a record. 4. Monitor and analyze performance. You cannot improve what you cannot see. Amazon CloudWatch automatically captures Lambda metrics like duration, error rate, throttles, and concurrency. Set alarms so you hear about problems before your users do, and analyze logs to find the slow spots. Treat this data as an ongoing feedback loop, not a one-time check at launch. 5. Optimize memory and timeout settings. Lambda ties CPU power to the memory you allocate, so memory is your most important tuning knob, and a higher setting can sometimes cost less by finishing faster. Test several memory configurations to balance speed and price. Set a realistic timeout so a stuck function fails fast instead of running up the bill. Tools like AWS Lambda Power Tuning automate the search for the sweet spot. 6. Environment variables. Environment variables keep configuration out of your code so the same function behaves differently across environments without redeploying. For anything sensitive, never store the raw secret in a plain variable. Reference AWS Secrets Manager or Parameter Store instead. Those services keep credentials encrypted and rotate them automatically. Lambda can also encrypt variables at rest with a KMS key. 7. Design for statelessness. Why does statelessness matter so much? Lambda runs many short-lived, isolated copies of your function, so it cannot rely on anything held in local memory. Push any state you need to persist into external storage like Amazon S3 or DynamoDB. This is exactly what lets Lambda scale from 0 to thousands of concurrent executions without breaking. API Gateway Integration. API Gateway turns your Lambda functions into secure, managed REST or HTTP APIs, handling routing, validation, authorization, and rate limiting. Cache at the gateway to serve repeat requests without invoking your function, and configure throttling so a spike cannot overwhelm your backend. Match the API type to the job. The HTTP API is cheaper and faster for simple cases, while the REST API offers more features. 9. Utilize event sources. Lambda's real power shows when functions react automatically to events. A new file in S3, a change in a DynamoDB table, or a record on a Kinesis stream can each trigger a function with no polling on your part. Pay attention to how each source handles batching, ordering, and retries, since those differ per service. Handling partial batch failures correctly keeps one bad record from blocking an entire stream. I should mention, this presentation is a condensed version of the complete article on blog.systemsarchitect.io. View the full blog article with more details there. 10. Adopt function versioning. Versioning lets you publish an immutable snapshot of your function, so a known good deployment is always recoverable. Aliases are movable pointers, like production or staging, so if a new version misbehaves, you roll back in seconds. Weighted aliases send a small slice of traffic to a new version first, a canary release that limits the blast radius of a bad change. 11. Optimize code size. A smaller deployment package uploads, deploys, and cold starts faster. Strip out anything the function does not need, including development dependencies, tests, documentation, and unused libraries. Packaging frameworks like AWS SAM or the Serverless framework make lean, repeatable builds easy, and moving shared code into a layer keeps the package thin. 12. VPC integration. Sometimes a function needs private resources, like a database in RDS, that are not exposed to the internet. Placing it inside a VPC gives access to those private subnets, but get the security groups and routing right. Only put a function in a VPC when it genuinely needs private access, since it adds cold start time, configuration, and cost. 13. Asynchronous invocations. Not every task needs an immediate answer. For work like processing an upload or sending an email, invoke the function asynchronously so the caller gets a fast acknowledgement while the work happens in the background. Lambda queues async events and retries them, with an on-failure destination catching anything that never succeeds. For multi-step workflows, pair async invocation with AWS step functions. 14. Employ provisioned concurrency. What does provisioned concurrency actually do? What keeps a set number of execution environments initialized and ready, eliminating cold starts for predictable, steady traffic like a checkout or login path. Because you pay for those instances, whether or not they are used, apply it judiciously. In 2025, it added response streaming support of up to 200 megabytes. 15. Enable X-ray tracing. As serverless architectures grow, a single request hops across many services, and finding the slow link gets hard. AWS X-ray traces a request end-to-end and builds a service map, turning a vague feeling that something is slow into a precise picture of the bottleneck. For debugging distributed serverless systems, this visibility is close to essential. 16. Built-in security features. How do you limit what a function can touch? Every Lambda function runs with an IAM role that should grant only the permissions it actually needs. This principle of least privilege means a compromised function can do very little damage because its blast radius is tiny. Avoid broad wildcard policies and review roles regularly. Getting identity right is the single highest leverage security decision in a serverless stack. 17. Manage dependencies efficiently. When dependencies grow large or need a custom runtime, container image support lets you package code and dependencies together as an image up to 10 gigabytes. Build from the AWS base images so your image stays compatible with the runtime. Keep in mind container images can carry longer cold starts than a slim zip, so reach for them only when size or runtime needs call for it. 18. Utilize resource-based policies. A resource-based policy attaches directly to your function and states who or what may invoke it, letting another AWS service like S3 or EventBridge, or even another account, trigger it securely. Unlike an execution role, which controls what your function can do, a resource-based policy controls who can call it. Scope each grant narrowly and audit them periodically to remove stale access. 19. Optimize deployment pipeline. Manual deployments are slow and error-prone and do not scale as your function count grows. Automate the whole path from commit to production with a CI/CD pipeline using tools like AWS Code Pipeline and Code Build, combined with versioning and aliases for gradual rollout and instant rollback. Infrastructure as code through AWS SAM or Terraform keeps configuration reproducible. The payoff is faster, safer releases. Taken together, these 19 strategies turn Lambda from a convenient way to run code into a deliberate, well-architected platform. Start with the highest impact items like cold starts, error handling, monitoring, memory tuning, statelessness, and least privileged security, then layer in networking, versioning, and pipelines as you mature. Get these right, and you will spend less, break less, and scale further, all while keeping the low operational overhead that drew you to serverless in the first place. Thanks for watching, and good luck building. Thanks for checking out this video. Hope you liked it. Find a lot more articles and guides both on systemsarchitect.io and codeguides.io. Again, that's systemsarchitect.io and codeguides.io.